Hi, welcome to the class. Today we will start one new topic of Unit 2, Current Electricity, and this is the first chapter of Unit 2, Current Electricity. So the name of the topic which we are going to start is EMF, Internal Resistance and Terminal Potential Difference. Now, EMF is, the full form is electromotive force, motive force. Now what it is? EMF is nothing but it is the potential, electric potential. Okay. Now electric potential already we have discussed, and it is defined as the work done per unit charge. Right? So it is the same thing, but in this case I call it maximum potential. Why do I call it maximum potential? So now potential we have already defined. So potential is basically work done per unit charge. Since I am calling it as maximum potential, so it is of course work done per unit charge. So this is work done. This EMF is work done per unit charge. It is maximum potential. So because it is maximum potential, that's why I am defining it like this. And I call it maximum potential because we say EMF when no current flows in the circuit. EMF is the maximum potential because of this reason, that when no current flows in the circuit or no current is taken from the cell itself, then we call it EMF. Okay. So now if you buy a new cell, okay, and there is a value of EMF which is written on the cell. Suppose I am giving just an example. So it is, let us say, 1.8 volt cell. So right now we have bought the cell, new cell, and we haven't taken out any current from the cell. Therefore its EMF will be 1.8 volt. I'll say its EMF is 1.8 volt. Why I will say? Because that would be the maximum potential between the two terminals of this cell. And why it will be so? It will be so because no current has been taken from the cell. So that is why we call it EMF, right? If I draw a circuit diagram, let us say this is the cell and this is the internal resistance of the cell. When the current flows through the cell, the very first resistance which is provided to the flow of current is provided by the cell itself. Why it will be provided by the cell itself? Remember that this resistance is nothing but it is the collision of electrons. So inside the cell also we have ions. Okay, charge particles moving here and there, and when they move or when the current is being taken from the cell, when they move, what happens? They collide with each other, and when they collide with each other, then what happens? This resistance is being created. So the very first resistance which is there in the cell when we take current from the cell is within the cell itself, right? So this is the cell. Cell is what? Positive, negative terminals, ion moving here and there, collision happening. Because of that collision, external resistance is there, and then we have an external resistance connected here, any bulb or anything, with the help of a key. So right now, as you can see, the key is not on. So if I ask you what will be the potential of this cell, so you will say, sir, this potential of the cell will be maximum because no current is being taken from the cell. And in this case, the maximum potential is what we call the EMF. It is denoted by this symbol E, right? So this is the EMF of the cell, correct? Now guys, if I tap on the key, what is going to happen? Of course, the current will start flowing. So current will start from positive of the terminal towards the negative of the terminal. So the very first resistance to the flow of current is being offered by the cell itself. So the very first resistance offered to the flow of current is by the cell itself, right? So if this I current flows through this resistance, so according to Ohm's law, we all know that V is equals to I into R, right? So when this current I will pass through this R, when this I will pass through this R, the product of this I and R, which is there, the product of this I and R is something we call small v, which is of course potential from Ohm's law, and this is what we call voltage drop. Voltage drop. So why this voltage drop has taken place? It has taken place because of two reasons. The very first reason is that the current started flowing through the cell, and the second reason is that there is an internal resistance of this cell. Okay, of this cell we have to consider an internal resistance, and because of this cell, because of this internal resistance, and because of the current flowing in the cell, this voltage drop has come, which is I multiplied by R. Is this clear? Right. Now what will happen? Can I say the potential of the cell right now, when the current is flowing and when there is a voltage drop, can I call the potential of the cell as EMF now? No, I won't call. Why? Because of two reasons. Number one, the current is flowing, and number two, there is a drop. There is a drop of voltage in the EMF. EMF is what? Maximum potential. Right? So there is a drop of this potential in the EMF. Okay? And why there is a drop? Because of this current I and because of this R, which is the internal resistance. Now EMF minus this drop. EMF is what? Potential. This is what? Drop. This drop has been come up. Why it has been come up? Because of the current flowing through the circuit and because of the internal resistance. So of course, from dimensional analysis we know that this EMF is a potential. This potential minus potential will give me another potential, and this will be the remaining potential, and this will be the potential at the ends of the cell now when the current is flowing through it, and this is what we call the terminal voltage. Terminal voltage, right? So this is the terminal voltage, and this is the equation which we all should understand here in this case. Now if you see, this EMF is greater as compared to this V. Why? Because E minus V gives me V, or if I send it there, so then EMF will be V plus V. Right? And this terminal voltage always comes into play when there is a current flowing in the cell, number one, and there is this internal resistance which we have considered. So if in place of V I can write. So this was EMF, E, terminal potential difference already discussed. Internal resistance is the resistance offered to the flow of current due to the collision of the ions in the cell, right? If I write these equations, what do I get? In place of V, I can write I capital R, and in place of this is terminal potential difference, this is voltage drop IR. E is equals to I capital R plus I small r. E is equals to I common R plus R, and if I calculate the current here, current will be R plus R. This will be the equation of the current, right? So this is how you can understand these three important terms, which are the EMF, terminal potential difference, and internal resistance, right? Now if I calculate an expression for R, and what is R? R is internal resistance. So can I write it as E minus V is equals to V. So E minus I small r is equals to V. Then this will go there. E minus V is equals to I small r, and small r is equals to E minus V upon I. Right? So if I write this, we shall remove this now. So if I write this in In place of V is equals to IR, we all know. So I is equals to V upon R. In place of this I can write V upon R. R is equals to E minus V upon I, and this is V upon R. This R will go up. So R will be equal to R E minus V upon V, and I can write it as R is equals to E upon V minus V upon V. I can write it separately. And if you solve this, it will be R is equals to R E upon V minus 1. So this can be another formula to calculate R. In some of the cases you might use this formula. So this was about these three topics. Now let us do few questions based on few numericals based on this. I shall remove this. I hope you understood this part. Electromotive force, this, and terminal interval resistance and terminal potential. So let me read out the question. The storage battery of a car has an EMF of 12 volt. EMF is given, which is of 12 volt. If the internal resistance of the battery is 0.4 ohm, if the internal resistance is 0.4 ohm, this is the internal resistance. What is the maximum current that can be drawn? Now this is the important word which they have used. What is the maximum current that can be drawn from the battery? If you want to take out the maximum current from the battery, you have to reduce the resistance. And how do you reduce the resistance? By not connecting the external resistance. So if this maximum is written whenever this R is always 0, right? So what I have to calculate? Maximum current. I have to calculate the maximum current. So I know one thing, E minus V is equals to V. So I have to calculate the maximum current. I have to calculate the value of I. And for I think we have already taken out the equation. If you remember, again I will solve it, but next time you shall minus IR is equals to I capital R minus is equals to IR plus IR. I common, then R plus R. So of course if this is 0, then it will be IR. So simply E is equals to I into R. So now I have to calculate this I. E is given, E is 12. I have to calculate, and this will be 0.4. So I is equals to 12 upon 0.4. I would be 30 ampere. So this would be the answer, right? If I tell you the other question of the same type, I have another one of the same type, and the question reads out: a secondary cell after long use has an EMF of 1.9 volt. EMF of 1.9 volt and a large internal resistance of 380 ohm. Large internal resistance of 380 ohm. Right? What maximum current? Again, they are using this word maximum current. So, what maximum current? So, when this current will be maximum? Of course, current will be maximum when this R will be 0. So, I will write just this equation I can use. I max will be equal to E upon R, EMF upon R. So you have to put the values. I'll just tell you the answer. You can solve it yourself. I'm not going to solve it. 0.005 ampere is the I max, right? Now one more, and again I'll read out the question. A battery of EMF 12 volt and internal resistance 3 ohm is connected to a resistor. So we have a battery here whose internal resistance is given, and this battery is connected to an external resistance or to a resistor, right? EMF of the battery is given 10 volt, external resistance is given 3 ohm, and this system is connected to a resistor. If the current in the circuit is 0.5, if the current in the circuit is 0.5 ampere, they are asking you to calculate capital R. So you all can try this. Again, E is equals to V plus V, E is equals to I capital R plus I small r. So you can use this equation and then try to figure it out that what could be the value of this capital R. So this is the first part of the question. Then what is the terminal voltage of the battery when the circuit is closed? They are asking you to calculate this terminal voltage also. If you are able to calculate this R, then you just multiply this R by I and it will give you the terminal voltage, because this capital V is the terminal voltage. So V is equals to I capital R. So in order to calculate the second part, in order to calculate this terminal voltage, you have to figure out what is R, right? So I suppose that you people will be able to do this, and I have to give you the answers. So if you try to figure out this, your capital R would be 17 ohm. Your capital R would be 17 ohm. And if you try to calculate the terminal voltage, that is V, terminal voltage. So that would be I 0.5, because this is the formula I into R into 17. So that would be your answer, right? So this would be 8.5 volt. I hope you would be able to calculate this part. 8.5 volt. This I have already explained. And if in case you people have any doubt, you might ask. You may ask this, right? Thank you.